Hello there, we are the Super Duper Sonic Chemists, and we'll be teaching you about how elements on their periodic table are individually unique.
To show this, we'll first be conducting a flame test lab. First, we'll have our materials.
So, we'll need our safety goggles to be safe. We'll need a small thing called nichrome wire to grab the salts.
We'll need a Bunsen burner, and we'll need water in case it gets out of hand.
And then we'll need a paper towel just to clean the wire. And we'll need small amounts of the solid, and we have a little flint starter to get the flame. First, let's get something out of the way. Elements have something called electrons, which are very small and also negative. They orbit around something called a nucleus, but we'll talk about that later. What I would like to say is elements have something very unique, just like fingerprints. Everybody has a very unique fingerprint and they're not the same, but also very unique. And except this flame test lab shows just that, but for elements.
Our flame test today will show you something really cool. These flames here is fire, or heat, which is a form of energy. Electrons get this energy really excited. Imagine sugar. When you eat a lot of sugar, you get really excited, you move around a lot. What they do is have our electrons move up an energy level into an orbital. An orbital is the area outside of the original electron path.
Now hold up. What's an orbital? And what's that thing inside of it?
That's a nucleus. It's very small and it has orbitals around it, and electrons orbit around it, and they go into different levels.
So we make electrons excited and go up a level. Well, what happens next?
The electron doesn't really like being at that level, so what it does is actually goes back down a level, and when it does that, it can't get rid of that energy, but it releases it as a photon, which is also a light.
Then the flame will be colored by this wave of light or energy. That's so cool.
Hello there, super duper sonic chemists. I'm here from the voice overlay and I'll be telling you how to be safe when performing this lab. So first, you're gonna need some goggles. Then, you're gonna have to roll up your sleeves so you don't catch anything. If you have any watches or jewelry, make sure to take it off. You wanna tie your hair back if you have long hair. You wanna have closed-toe shoes. Alright, so you'll need some materials. You need the Bunsen burner, you need the plug, and you need the salts. Then you're gonna have to take your nichrome wire on those salts, and then you're gonna start the lab. But first, you have to start the fire, turn the lever, let the gas out, and then you're gonna put the flint starter over it, and just let it rip. Boom! Alright, let's get this lab started. So he's cleaning the nichrome wire. Then he's going to pick up the salt. The salt we're using currently is calcium chloride. It's going to change the color of the flame. And you'll see that very shortly. Now it's hard to kind of see, but there's a hint of green. The flame is changing color and reacting to the electrons moving levels, which is releasing the waves of photon, which is the light. And now you saw that little bigger flame of green. Alright, so you just saw the calcium chloride. Now you'll be seeing the strontium chloride. He's gonna clean it, dip it in, put it on the flame. Now there's a lot of like powder on it, so it might take a bit, but you can see like some yellow. It's a little more difficult to see, but we did try our best, and it kind of changed the color of the flame. Even though it looks orange, yellow is like, very close to that same color. Alright, for our last experiment, we'll be using some barium chloride. He's gonna dip the nichrome wire, clean it, and pick up some chloride. So he has a lot on the nichrome wire, and as you can see, once he puts it in, it just turns red, a beautiful red that is very prominent and looks so cool. It kind of dies a bit, but it does continue, which is really cool. Alright, very quickly we'll show you what to do when you're cleaning the lab. You're going to turn off the gas so the fire doesn't burn you. You're going to pull that little plug so all the gas doesn't go back into it. Then you're just going to clean up the lab.
Now that was amazing. Who could have known fires could change color?
Have you ever heard of fireworks?
No way, really?
Yeah, those work the exact same way that our experiment just did.
Awesome. I have some common questions I want to ask. Can I do this at home?
Sort of. You need an open flame. I would recommend a campfire, because that's the easiest. And you just need to buy some of the materials online.
Okay, another question. Why are the colors different?
Again, since every element has a different orbital, and the electrons move, they might leave a different trail. That makes the colors different.
Okay, awesome. No more questions. What we'd like to remind you is that every element is unique, just like every person's fingerprint.
We can identify this because electrons jump energy levels but go back and release light.
Isn't chemistry amazing? That's it for now, you super duper sonic chemists.
Remember to be safe and keep loving chemistry.
Sonic Chemists out!